All right, let's look at tension, one of the forces that we are going to be discussing. So let's say if I have a mass hanging on a string, let's make it 3 kg. And the question is, what is the tension in the string right here? Our first process is to make a free body diagram. Remember, a free body diagram, the object that we're interested in finding the tension on, which is the string. If I make a free body diagram on this mass, I have a force acting upwards as tension, and another force acting downwards, that's gravity. We know these two equal each other because the object is at rest. There's no acceleration. So if I were to add up the forces here, the sum of the forces in the y direction is equal to 0. Mainly, I know this because the object is at rest, which means that the sum of the forces, we have Ft acting upwards and Fg acting downwards. And so Ft must equal Fg. The force of gravity of an object is simply its mass times gravity, be 3 times 9.8 meters per second squared. And that would be my force of gravity, which should equal to the force of tension. This is equal to 29.6 newtons. And since Ft equals Fg, that tells you that the force of tension is simply 26.9 newtons. And that's how you could figure out what is the tension on a string of something that's simply hanging in one place. Now let's do something different. Let's lift this mass up at a constant velocity of 2 meters per second. Well, if I'm moving at a constant velocity of 2 meters per second, that still means that my acceleration is 0. The net acceleration is 0 because the object is not speeding up or slowing down. So again, Ft is going to equal to Fg. Again, when I make my free body diagrams, I ask, what are all the forces that are acting on this object here? And there's only 2 forces, tension pulling upwards and force of gravity pulling downwards. They both are equal again in magnitude. And so using the same process again, Ft minus Fg is equal to 0. I have Ft equals Fg. And again, Fg is mg, which is again 29.6 newtons. And so again, the tension in this case is 26.9 newtons. You see exactly the same thing would happen if this object were being lowered at 2 meters per second, or it could be 3 meters per second. It's really not going to make any difference. And if it's being lowered at that velocity, again, it's the same thing, Ft equals Fg. And so, again, my force of tension using the same process I had upstairs would be 26.9 newtons. Okay, so whether an object is at rest while it's hanging or being pulled up or let down at constant velocity, the tension still remains at 26.9 newtons. Okay. And so that's basically finding tension for a simple, non-accelerated motion for any object.